In this video, we're going to look at 69.3, or topic 69, section 3, example 3, but we're going to use technology with matrices. So we're going to be given a system of equations, and we're going to take that system, plug it into a TI-84 calculator in this case, and use reduced row echelon form to find the solutions. It's kind of a four-step process, but the first thing we want to do is we want to have this in standard form. All right, so we need our equations in standard form, which means if you have three variables, you want x plus y plus z equals whatever your constant is. All right, some kind of constant over here. So equation 2, this 4x plus 3y plus 2z is good. We don't have to do anything with that. The x minus y equals z, so this one here, I do need to rearrange that, and it's a pretty simple step in this case. I would just subtract z from each side, so I get x minus y minus z is equal to 0. So that equation becomes that there. Like I mentioned, this second equation is good already. We have x, y, and z, so I'll just copy that down. So we'll call this equation 1. Equation 2, we have 4x plus 3y plus 2z equals 6. That one's done. We don't have to do anything else. And then equation 3, this 2y minus x minus 3 is equals 13. It looks good, but we actually need to rearrange it. So you have 2y minus x minus 3z equals 13. We need to have the x value first. So I'm just going to rewrite this as negative x plus 2y minus 3z is equal to 13, and this would be our third equation. So I'm going to rewrite those in order so they're kind of organized a bit more neatly. So we have x minus y minus z equals 0. We have 4x plus 3y plus 2z equals 6. And negative x plus 2y minus 3z equals 13. So that's the first phase. We have everything in standard form. Next, we want to convert this to an augmented matrix. So we're going to convert it to an augmented matrix. And remember, that's where you have your dotted lines, right? So we have the constants or the coefficients in front of the variables, and then we have our constants. So here, I'm going to highlight these again so we can just kind of follow along. The first one, we have a 1, negative 1, negative 1, 0. Those are my coefficients, and the constant is 0. So we'll keep highlighting. Second one, we have 4, 3, 2, and 6. And then the final one, we have negative 1, 2, negative 3, and 13. So that's the second step. First, you need to make sure they're in standard form. Sometimes they already are in standard form, but if they're not, we want to put them in standard form. Then we would write our augmented matrix. Once you have the augmented matrix, you can then enter that in the calculator. So on the right here, I'm going to hit second, and then this x to the negative 1 key, 3 keys below it, where it says matrix. So you'll get this screen where it says names, math, and edit. You want to scroll right until you get to edit. We'll choose matrix A in this case. We're going to hit enter. And now they're asking us for the size of matrix A. We want rows and columns. So if we look here, back at our matrix, our augmented matrix, we have 3 rows and 4 columns. So for our calculator, we're going to say 3, enter, 4, enter. And now we have a 3x4 matrix. There's a chance the handheld calculators, that 4th column might be off screen. It is there, but just be careful with that. Once you have that typed in, or once you have that setting, so the rows and the columns, you're then going to type in your matrix. So I'm going to do the first row, which is 1. So after each number you type in, you would hit enter. So 1. Now I would have negative 1. Make sure you use the negative symbol and not the subtraction sign. I have another -1, and then 0. And then just keep entering each row. So row 2 would be 4, 3, 2, and 6. And then row 3, -1, 2, -3, and 13. Once you have that entered, I always recommend checking to make sure that it's already typed in. And in the handheld calculator, since you can't see column 4, you're going to hit second mode, which will quit back to the main screen, then hit second matrix, and then just select option A. So hit enter, you'll get that A there, and hit it again, and you should get the matrix that you're looking for. Just make sure that matches up with the augmented matrix that you have written out. If those match, you're good for the next step. So we can clear this. You can leave it if you want. I'm going to clear it just so it's out of the way. You're then going to go back to your matrix kind of page. So we'll hit second matrix. And this time we want to scroll right to math. And what we're looking for is we're looking for something called reduced row echelon form. And where that is on the calculator is if I keep scrolling down to option B, you'll see that I have RREF. That stands for reduced row echelon form. You want to hit enter. So now we have that on the screen with the parentheses. Hit second matrix again, and then choose the matrix that we want, in this case A. So it's already highlighted. I'm going to hit enter. Close your parentheses. So just end that parenthesis there, and then hit enter one more time. So now we have this matrix where we have 1, 0, 0, 0.5, and so on. That is my reduced row echelon form. So I'm going to copy that down. So I have 1, 0, 0. Make sure we put our dotted line. 0.5, 0, 1, 0, 3, and 0, 0, 1, -2.5. What this means was that for that first row, they're telling me that x is equal to 0.5, y is equal to 3, and z is equal to -2.5. Now I know that because remember that this piece here, right, this is our x column, so this piece would be x. And there's no y and z on this row, so x is equal to 0.5. Then you have your y column, right, this one here, so y would be 3. And then you have your z column, in this case z would be -2.5. The final thing you should do is you should write your final answer as a point, so 0.53, -2.5, and then just box that in, and you're done. Sometimes the equations will already be in standard form. If they are, great. If they're not, put them in standard form, then write out your augmented matrix, type the augmented matrix into the calculator, use the reduced row echelon form function on the calculator, and then just interpret what that reduced row echelon form actually means, and you'll get your solution.